Okay, so today we were talking about another new classification algorithm, including the FVM, random forest, and voting. Okay, so first of all, we will introduce the support vector machine, also we call it FVM, 支援向量机 support vector machine. What is that? Support vector machine, we also call it support vector classification, SVC. Is a support vector machines for classification. Actually, FVM have two different models. One is for SVC for classification, and the other one is SVR, so support vector regression. So there are two packages in Python. The Python will have package, but it basically is SVM. Okay, so this is suppose we have a two dimension. One is X1, the other one is X2, and these are two categories here, and we want to find a line or a plane, okay, to divide it two categories very clear. So we can find this line and also can find this line. But which line is better? Maybe we can consider this line more bold one. Why we think it is the better? Because we want to know which one is the best. Okay, so we have to find the margin. So suppose we use this red line, the margins of two categories is maximized. 这个边际是最大的 maximize margin 边际. And this part for two categories, plane of the row, just like the margin, we call that support vector. So classify the data by a hyperplane, 小平面. Then maximize the margin, maximize 边距 at each class is in the training sample points. So this is called support vector. 所以呢 support vector 呢其实是重要的资料点，在边际上的资料点，是两军对峙负责站位兵的确认。It's make sure the distance of two categories is maximized. So the sample point close to the margin is called a support vector. 这些点扮演了很重要的角色. They played a very important role here. So we call that support vector. And how to find it? If you want to split two-dimensional spaces, you need a one-dimensional hyperplane. That is a line. 如果你想切割二维的，那你需要一条线，好，这就是超平面嘛，哈，一个线降一维就行了。And to split three-dimensional spaces, you need a two-dimensional hyperplane, such as a piece of paper. 如果我们今天在一个教室这个立体的空间，我们要切成两个不同的 category, we just need a two-dimensional hyperplane, 就是二维的，我们用一张纸就可以做切割。So you can find there is a rule that if you want to have a split two-dimensional, you just need one-dimensional, 减一minus one. If you want to split three-dimensional, then you just need a two-dimensional. But no matter what, we'll call that hyperplane. Hyperplane 就是一个超平面 because we don't know how dimensional it is. But actually, it will just depends on your attribute. 你的 attribute 决定你是几个 dimensional. 那你的 hyperplane, your hyperplane, just your attributes. Suppose we have n attributes, you just minus one. That is composed in your hyperplane. So, 如果它是一个非线性的 nonlinear classification, we can add a kernel function. 我们用一个和函数就可以让它处理一个 handle a nonlinear classification. So the SVC have a frequently key parameters. For example, C penalty parameters. Okay, you can control the regular strength of the model. Large C means the model tries to classify the training data as accurately as possible, hence to overfit. If the C is too large, it will be more easily overfit. But small c, it will allow more classification error. The model becomes smoother and more generalization, but usually have a decreased accuracy. 这样就是 accuracy 会比较低. So the larger of the C, the harder of the margin. 这个就是边际会更明显. The small of the C, the soft of the margin. Yeah, this is the first 乘法函数、乘法系数 penalty parameter C， 它可以 is can control the regular strength of the model， 用那个控制这个边际到底有多强悍。Okay, the second one is kernel function. Kernel function is determining what feature space of data will be classified. 如果 suppose if your kernel is linear, is for linear separated data. If it is a it's a polynomial kernels. It handles non-linear boundaries. And we can also use the RBF, it's default. RBF means Gaussian, Gauss RBA, most commonly used and performed back in most cases. So it is the default. 这个是非线性的non-linear 的这种 classification will use RBA is have a fast performance. And also you can use the sigmoid. Sigmoid is similar to a neural network activation function. 这个跟逻辑思维有关，或者是跟neural network activation 是有关系的。So most common choice, if you for nonlinear problems, please use RBF. If you use the high-dimensional text data or linear separated problem, please use the linear. So which one we will use? I will give you the instructions in the exam. 我们要用哪一个在考试里面我会告诉你。So also there are another key parameters, especially in the RBF kernel. 用 RBF 的时候 there is a gamma parameter. So in kernel function, especially in RB kernel, the gamma determines the influence ranges of a single training sample. Large gamma means small influence range. It means the model will become very curvy, prone to the overfitting. 这就变得非常的曲线。Small gamma means large influences range. The decision boundary will become more smoother. So it can determine your gamma. Okay, and default options. Okay, other scale recommended adjust automatically based on the feature values. And auto use this 1 divided to n features. Okay, so this also have some class weight used to handling imbalanced data. SVC, SVM, we will vary. 我们非常担心 worry about imbalanced data. 在没有抽样之前，我们担心这个。You may set class weight. For example, class 1 we give the double weight. Class 0 we give the 1 weight. Also, you can manually assign higher weight to the minority class. If you have a minority class, for example, class 1 is more important, but the examples here is less, we can give the higher weight. 所以我告诉你哦，如果你的资料低 class 1呢比较重要，但是它的资料量少，你可以用手调的给它weight比较高一点点。否则 SVC 它容易切的时候呢，就容易切的不好。You can also use the default balance. Automatically adjust class weight inversely proportional to the class frequency based on his class frequency. So make it is 2 categories balance. This means it will adjust automatically less. 所以这少的资料它会自动权重调高，多的资料会自动权重调低，然后 anyway 它最后会把它 balance， 所以它会 inversely proportional to the class frequency。这个是自动把它调到两边一样。So this kind of problems will very suitable for the forward detection. OK， 记起来 ，forward detection 诈欺，因为 because forward detection is rare event。Or disease classification 疾病的侦测，比如说疫情那个时候染疫的很少，还有 especially suitable for the imbalanced data set， 这个都非常的合适因为它有这样的机制。So for SVC, please, this is very important. Maybe appear in your exam, right? So we will use the Python code to model it. Okay. So please, we use the data set from our here, our time class. Here, we can find the floater. Okay, this is last week. This is this week. Okay. Data sets. Rubik's data sets. Maybe we can use, oh no, reach out. Let me see. Oh, this one. Oh, actually here. Okay, we can find the data. And we use the no mixing value. Okay, it's more easier. Okay, let's go. Spider. So please download the no missing value here. I'll be in the desktop. Okay, so it's dated as today's date. Obviously, today is 2026. Oh, it's June 2nd. And it's in author. And today's topic is SVM. Okay, as stated, I want to use SVM. It's more clearly because we will handle a lot today. So this is SVM. So first, we import the pandas with PD and make the data inside that equal PD with CSV. Okay. We import this data. No missing that is more easy. So we copy. Here. Okay, and first we run it and check the variables out here. And also we can do some data explorer to check there is no missing value. Okay, it's good. Okay, after that, today we don't use any attribute of it. 我们不用所有的变数 because SVM because SVM must all numerate variable. Attribute. 所以必须 at least you have to at least the label encoder, label encoder. Or one-time encoder. And you have to transfer, but today we don't want to use every attribute today, and we just use the subset. Would you please speak not so loud? Oh, sorry, because this will report it inside. So today we demonstrate the subset. 就是子集合。So today we just use the subdata. and we just find 这个概念是会考的，所以你要用对吧？ We use the bank region, but the region, not every region. We just use the inner city. But this part, we just want it as our target variable. Inner city is the first one, and 好，这里有一个 vertical bar， 这个一竖呢是或的意思 or vertical bar means this is a vertical bar 啊，这个一竖 represent or we want the region as inner city or the town or rural 乡村。We want these three places. 第二个是有括号要有 these three. Okay. Okay. Try this subset will be 365. 这里会有365资料。And check whether you are correct or not. Town, inner city, rural. Then you will just have the 365. Is that clear? Is that right? Is it? No? Okay. I maybe have something wrong. Inner city. Do I have something spelling wrong? Oh, okay, sorry. Spelling wrong. Here, 538, right? Okay, good. Thank you. So this is our data set. This is want to be our Y. So X will be S sub data. 这个 data set 里面，我们只要 we just want because we need 那个 continuous variable， 这里面有3个可以用。We use the age, income, and the children. Children, because these 3 attributes is numeric， 我们就不用再做 label encoding 了。So we want to use the age, income, and children determine whether the region you live. So here, use the age, income, and children to classify the region of the customer live. So this is our X. And okay, SVN X, the target variable need to numerate, but it's just because Python package. Not for the method. It means we have to be numeric, but it's just because the Python package, not for the method. The methods specifically do not have to transfer. Okay? So the Y here, we make it as a subset. Subdata of the region. So the X will be the 3 categories and the data will be the region. And this attribute need to transfer. That just because the Python package， 因为 Python 的 SVN 必须要，但是其他的你用的是其他套件是不需要的。So for it, we need to do from expander dot preprocessing import label encoder. Ah, 那你会问我说，老师为什么这里又用 why is it label encoder not Wi-Fi encoder? Just because if you use the Wi-Fi encoder, you will divide it into 3 attributes. 因为如果你用 Wi-Fi encoder, 它又变成3 attribute, it cannot be used. So we have to use the label encoder. This is the limitation of this Python package. So y equal the label encoder bit dot bit and transform y. So our y is become memory. Good. And also, I want to let you know we need to do, you remember, we need to do the standard deviation. 我们需不需要做标准化 for SVN? Yes, we need. Remember, 我们有说过 KNN, SVN, K-means, all need the standard scalar. But 我们是先切资料 we split the data first, or we make the standard deviation first. Which one first? Cut the data first, because the testing data have to fit. 测试交集必须要配适 training data set, have to fit the training data set. So we cut the data first. If we want to cut the data from expander dot preprocessing and model selection dot model selection. 先资料就是 model selection. Split data use the model selection. Train task split. And then today is the X-train as a task with the Y-train and the Y-task. So we can use the try task select. And here, X and Y and to task size. Task size equals 0.2. And also we give the random state, today's date. Okay, then we know everything. Okay, so our train here, I want to use method. Sorry, the number is totally the same with me. I will stop here and let you follow up.